what I now want to talk about is how do we make a claim from data. So we're going to do this one together, and then I'm going to have you guys do this one alone, and the end two, sorry, alone. Okay. Or you know what, I'm actually going to do these two with you guys, and then we'll have the other ones be for homework. So, making a claim from data. What we want to do, this is kind of steps we've been following this whole time, is what's your independent variable, what's your dependent variable, how did the IV affect the DV, and then what data supports that claim. So first, what's the independent variable? What was changed between each group? So what it looks like here to me is we had one group sitting, one group walking, one group running. And it looks like those who were sitting had a volume of 20 liters per minute of exhaled air. Those walking had 40 liters per minute. Those running exhaled over 80 liters per minute. So what changed between each group is the level of physical activity. Okay, and then the dependent variable, what was being measured throughout the lab? It looks like they were keeping track of how much air they exhaled. So volume of air exhaled. Okay, so what we would want to do when analyzing a graph is kind of start with that general claim. What does it look like? So as they went from sitting to walking to running, so as they increased their physical activity, did the amount of air exhaled go up? Did it go down? Or did it stay the same? I think we can all comfortably say that it looks like it went up. So the claim we can make about the effect here is that as we increased level of physical activity, we increased volume of exhaled air. So I encourage you to kind of always have this same structure for your answers here. So we say as we either increased or decreased the IV, we either increased or decreased the DV. So it's kind of like a little sentence structure that you can follow. As the independent variable went up or down, the dependent variable went up or down. And then it's super important you actually use data from the lab to support that claim. So what you would want to do is pull out those three pieces of data. So when sitting, I'm just going to zoom in a bit here. So when sitting, around 18 liters per minute were exhaled. When walking, around, oh no, not even around, exactly 40 liters of air per minute were exhaled. When running, looks like about 83 liters per minute were exhaled. And so by stating those numbers, you're showing that as the level of physical activity goes up, the amount of air exhaled also goes up. So you want to use your data to support that. Okay, let's do the next one. Okay, so what's the independent variable? What are they changing? So the title of this graph says to me the number of bubbles produced per minute by plant X, so some sort of generic plant, in various depths of water. So it looks like they had plants at varying depths. Not necessarily consistent, just varying depths, if we see that. Okay. And then they were measuring how many bubbles per minute were produced. And these bubbles would contain oxygen because that's what plants produce when they photosynthesize. So the independent variables, they changed the different depths the plants were at. So depth of the plant. And then it looks like they were measuring the bubbles produced per minute of oxygen. Okay, so how did the IV affect the DV? Let's go back to our formula. As the depth either increased or decreased, the amount of bubbles produced either increased or decreased. So as depth increased, it looks like we don't actually have a straight relationship here. It looks like what we have is it increases and then it decreases. So we can say it increases until this point, which is about 10 meters, and then it decreases. So the amount of bubbles produced increased from depths 0 meters to 10 meters. Once the plant went deeper than 10 meters, the amount of bubbles decreased. Okay, and then when we have as much data as this, you don't necessarily need to talk about every piece of data. I would start looking at the specific ones that are important here, so the landmark ones. So this initial point is important, this peak is important, and then when we get down to the lower, the depth is important. So I would say at roughly probably 2 meters, about 28 bubbles were produced a minute. At 10 meters, 45 bubbles were produced per minute. And then at roughly 36 meters, about 8 bubbles per minute were produced. And so again, if that is supporting the claim that we made in part 3 right here, part 3, that the amount of bubbles increased as you got to 10 meters, and then once you go past 10 meters, it decreased the amount of bubbles produced. So go ahead and try practice problems number 3. This is super related to what we've been doing in class lately. And number 4, this one again is related to what we've been doing in class lately. Both of these are diffusion practice problems. And then your teacher should go over the answer to these with you guys. All right, good luck. Please contact your teacher if you have any questions.